Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and we are talking about the NASA Artemis program. Today, an Artemis 1 mission. Hey, Ben, how are you?
Hey, I'm good. How are you, Simon? Hey, fellow Econauts.
I'm very well and I'm very excited. Number one, because I think it's amazing that we are going back to the moon. And of course, also in honor of the TED talk that you are attending as a guest speaker on the 24th November 2023. Should we jump into our show today?
Absolutely.
Absolutely. We have something special for you. We are talking about the first mission, the Artemis 1 mission. And for that, we have the official map from NASA that we will have now on screen. Maybe you can walk us through that a little bit.
Yeah, I will do that with great pleasure. As you can see, this is a not to scale infographic. First of all, the moon is way further away and so on. So this is really just to explain what's going on here. And also, secondly, Artemis 1, the Artemis 1 mission is already done last year. So this is you could say it's a bit of a review. But Artemis 2 is happening very soon, and obviously we will also talk about that in the next episode. The infographic shows us the pathway and different stages of the mission. Maybe first of all, and you can see that in the infographic as well, the purpose of Artemis 1 was to test the SLS, that's the rocket booster, and also the spacecraft Orion before we actually put anybody in danger on board.
If you don't
So
mind, I'd like to show the Orion rocket real quick so that people can take a look at how the rocket looks like. By the way, all the information that you see here are the official information from NASA, and we will have links in the description. Okay, sorry.
yeah,
Just go ahead.
minor correction, it's the Orion spacecraft.
So,
So the rocket,
okay.
it's all good. The rocket is SLS. SLS, just in a nutshell, is a heavy launch rocket to push the payload, in this case the Orion spacecraft, into orbit, and then also to give it the boost needed to go to the moon. It uses the old space shuttle boosters for that. But enough of that. Quickly to the Orion spacecraft. The spacecraft is also made up of four parts. We have the launch abort system, which is the tip, the actual crew module, which is the little tiny part where humans will be sitting in. So this is all they get, the whole rocket and everything's just to send this little crew module there. And obviously there's also other payload on the rocket, but that's the important part. Then we have the service module, and we have a spacecraft adapter, which connects the rocket with the spacecraft. The whole purpose of Artemis 1 was mainly to test a number of things. First of all, the SLS rocket. Maybe on a little fun fact or fact, and on this side, they had to abort the launch a couple times because of a leakage seal. And therefore, obviously, they couldn't launch in the first place. Eventually, they did launch, and the whole Artemis 1 mission was a great success. Coming back to the infographic, so the first 6 stages are pretty much the launch. One is the launch from the SLS with the Orion on board. At some point, the rocket will sort of go to the right orbit. Then the rockets will turn off, the boosters will cut off, and will just fall back into water. Then the whole spacecraft, including the little ICPS, which is like another booster, will stay in orbit around Earth. The ICPS then gives the spacecraft another push to then transit from the Earth orbit into a transit orbit to the moon.
On number 7, there's already a separation going on between the
Yes,
spacecraft, right, and the rocket.
exactly. So the main rocket is already separated.
Yes.
That happened way before that. So the boosters, when you see on the infographic, the orange part, that's SLS. The white parts on the side, these are the boosters. The boosters, they get separated first. The main rocket will take over and gives the main push to get into orbit. At 6, that's what I mentioned just before. The ICPS is the interim cryogenic propulsion system, will give the Orion a final push. And then at 7, there's a separation between Orion and the ICPS. The ICPS, maybe on a side note, you can see that here as well. still has its own mission deploying CubeSats on the pathway and also orbiting the moon once and then leaving into space, into oblivion. Coming back to the Orion is then transiting to the moon and at some point obviously reaching the moon orbit and doing the first close flyby on the infographic here indicated with the number 9. These close flybys are very important because obviously once we have people on the Orion, we need to fly by closely to actually land something on the surface and then finally.
So the close flybys are simulating more or less the landing.
Not the landing itself, but getting close enough to do a landing. So it's an important part of the mission success to see that all the systems are working. The close flyby, the moon has no atmosphere, so therefore you can actually fly by very, very closely if you want to, because there will be no drag from atmosphere, so no slowdown. But so obviously you don't want to crash into the moon, so you need to test that everything is in order. Yeah. So then the gray part is the distant orbiting around the moon, where when now people would be on the moon, the spacecraft some people will remain on the spacecraft to sort of do a transit and to then finally do another flyby where the pickup will happen. So when people are on the moon, they have to get obviously back on with another booster and lander back onto the Orion spacecraft, which then eventually will go back to Earth. So we are now entering the bluish pathway, which is pretty much transiting now the spacecraft back to Earth. And then at 15, the actual crew module will separate from the spacecraft and will splash down in the ocean at 17. So the descent will then happen in the atmosphere, and there will be a lot of heat generated, a lot of deceleration. Finally, the parachutes will open and then it splashes down. Yeah, that's pretty much.
That's pretty much it. So we can, I think we can very well see number 15, the separation, and then we just have to imagine that the blue line is behind the Earth, and then 16, 17, around, right? Yeah. And we can see with 17 they have like little parachutes indicating that they are landing in the ocean. Right?
Yeah. That's pretty much the same what they did with the Apollo mission as well, with the Saturn V. Nothing really changed there other than they obviously have way more modern spacecraft and rockets they use for the whole mission.
That's fantastic. And so the entire mission will be like how long?
The whole mission, you can see that on the infographic as well in the upper right corner. So the whole mission duration was 25 days and 10 hours to be completely exact. The outbound transit, that's all the orange part, lasted for 9 days and 13 hours. Then the gray part around the lunar surface was for about a week, 6 days. And the return transit was also 9 days and 19 hours to come back to Earth.
Fantastic. And this is pretty much the same that they are also doing with the manned module, right?
Yeah, pretty much. I mean, obviously there will be a couple things which will be different. For example, the CubeSat deploy. I'm not too sure. We will look into the detail once we are talking about Artemis 2. But I believe the CubeSat deploys was just for Artemis 1. Maybe there's another deploy on the way, which we will see. But pretty much, I think one special thing which I find is very cool about Artemis 1, you could in advance get a ticket for Artemis 1 on the NASA website.
Yes, I got one
too. I got one for my whole family, and I think that was a cool thing. Yeah. What they did is they collected all the names from everybody who registered, put everybody the name of everybody in a list on a USB stick, and that USB stick was actually flying on the Orion around the moon. So I think that's pretty awesome. So my name, your name, and everybody who registered flew actually once around the moon. I think that's pretty cool.
Yeah, it's fantastic. I think that's also why we have like a special connection to that program, because we feel like we are, even if it's just a silly teeny tiny bit, but kind of part of it. Yeah. I think this is absolutely amazing. Yeah. And that's also why I think it's so important to talk about that. It's a very cool program. I'm very happy that we are going back to the moon. I mentioned that many times in the past episodes, and I'm very much looking forward to Artemis 2. Can't wait for the astronauts to actually go back to the moon. Even it's just, I think they are not landing, right? Are they landing this time?
This time they will, so Artemis 2 will not be landing. It will be another test of everything. So it's the perception of space is obviously very, it's dangerous. Why do we do this and so on? And I think a lot of people like us, for example, we work very hard to convince people and to like about the benefits going to space, not just for exploration and research, what NASA is doing, but also for a lot of economical reasons. But obviously, you have to be very careful to
Right.
not have it to not end in a disaster. So
Absolutely.
you want to test
Absolutely.
everything really to the T. That's why Artemis 1 didn't have a crew on board, just to test everything, that everything is fine, everything works. And now the second one, Artemis 2, will also just I mean, that's a huge achievement.
No, absolutely.
How many people
Absolutely.
can say from themselves that they have actually circumvented the moon? So yeah, our four astronauts will go onto the Artemis 2 mission on the Orion and fly by the moon.
Let's talk about Artemis 2 in our next episode. I'm very happy that you were tuning in today, and I think you can already tell that I'm very excited about Artemis.
Absolutely, yeah.
And
I watched the launch from Artemis 1 and will definitely watch the launch from Artemis 2.
Yes. I think this is absolute amazing, and I thank you for tuning in. And if you like this episode, please don't forget to leave a like and write a comment in the comment section. If you haven't already, subscribe to our channel, and there's a little notification bell. I know that you wanted me to say that.
Yes. Hit the notification bell.
Hit the notification bell. Smash that like button. All right. Okay. We'll see you next time. All right. Bye-bye.
Bye.
Bye.